All right, so in this chapter, we're looking at absolute value. Now, the absolute value of a number x is written as the absolute value of x. And so you see a number in between two straight lines. It is the positive distance of a number from 0. And so here we see our integer number line. We see the positive values on the right side as green and the negative values in red with 0 in the middle in purple. Now, just to give you an example, if I was to find the absolute value of -3, it will equal 3 because it's literally just telling me the distance between -3 and 0, as you see here. And it's only 3 units. Also, if I was to do the absolute value of +3, then my answer is still +3 because the absolute value of 3 is still just telling me how far am I away from 0, which is still 3 units. And this often comes in handy when dealing with real scenarios. Let's say the prime meridian and you were treating the distance from the prime meridian. You can show on a number line that on the western hemisphere can represent the negatives and the eastern hemisphere the positives. And so although you might go 20 degrees to the east and 20 degrees to the west, you still have gone 20 degrees. And that's what absolute value is. It's just making sure you understand the distance even though you're heading in different directions. To solve an absolute value equation, use the fact that x can have two possible values, as you see up here on our diagram, a positive value or a negative value. So for instance, the absolute value of x equals to 3 can have x to be 3 or -3, as we see in our diagram. So if I was to work backwards and solve, you would see that -3 and +3 could be the values of x when the absolute value is simply 3 units away from 0. Now we have to keep that in mind because when you're solving an equation, you have to decide sometimes on that. All right, so now let's look at an example. We're going to solve an absolute value equation where the absolute value of 3x subtract 4 is equal to 5. Now because it equals 5, that just means the total distance away from 0. So that means it could be -5 distances, or -5 units away from 0, or it could be +5 units away. So when we write this out, we want to make sure we write it as 3x subtract 4 could be equal to -5, or 3x subtract 4 could be equal to +5, because it could be either one inside here. We know it could be -5 inside the absolute value or +5. So now we go ahead and solve, and if we do the opposite operation there, starting with the weaker operation, we get 3x is equal to -1, and so x is equal to a -3rd. On this side, if we add 4 to both sides, what we get here is 3x will be equal to 9, and dividing by both sides, we get x equals to 3. All right, so we get two possible values there, a -3rd and a +3 that could work. And if you used to substitute in there to check, and you said 3 times a -3rd, well, that's going to give you -3, and -1 subtract 4 is -5, and the absolute value of -5 is 5. And if you were to substitute this one in here, 3 times 3 is 9, 9 subtract 4 is 5, and the absolute value of 5 is 5. All right, so now let's go on to some rules when dealing with absolute value and inequalities. And so if you remember in our previous lesson, in chapter 1.6, that we were dealing with inequalities. Well, what happens when you mix an absolute value with an inequality? Well, the first thing is the inequality of the absolute value of x less than c, where c is greater than 0, means that the inside linear expression is between -c and +c. So basically it's just saying if you get less than c, you're dealing with like an and statement. Whereas if you get if it's written as greater than c, you'd be dealing with an or statement because you're going beyond -c and +c. So remember, the or statement will look like this. It could be an open circle going in one direction and another closed circle going in the other. It could be open or closed. Whereas in the and statement, you would look like this. And it could be open circles as well. And so basically you can tell by the initial statement. And if you think about it, if I have a number that's less than 5, then there's only one option that's possible. That the other value, it has to be greater than in order for it to be less than 5. So if I had 5 here and it was greater than, there's no way that I can be on the left side unless my numbers are going less than some other number. And so basically you can tell by if it's on the greater side or the less than side. And if it is, you can determine what your inequalities will be. All right, so remember you can replace the less than and greater than sign with less than or equal to or greater than equal to sign, and this rule still stays the same. Okay, so now let's go ahead and try solving an inequality in this format. All right, because it's less than 11, if you can visualize that, once again, if it's less than 11, it has to be on this side. Because it's less than 11, the only way that this can satisfy is if the other unit, and this is just a scenario. When you solve that, it won't be 11. But just gives you an idea of how it works. That means the other side has to be a number that's in between. And so basically you know that you're going to end up with an AND statement there. All right, so let's go ahead and work this out. We know that we can have it to be between negative 11, that's our other possible value, so we can rewrite this as a compound statement and have 2x plus 7 less than 11, as we can visually see in the example I just did. And so now we could go ahead and solve that, and we have subtract 7 on all sides. The 7's here cancel, and negative 11 subtract negative 7 would be negative 18, less than 2x less than 11, subtract 7 is going to give us 4. And then we could divide all the sides by 2. And so when we do that, we get negative 9 is less than x less than 2. And if you were to put this on a number line, you would see it as negative 9 is here. And let's just put 0 there. This is a rough sketch. We will have our numbers are less than 2 and greater than negative 9. So everything inside that region. Okay, let's try it again with a statement that would look more like the OR statement. So we have the absolute value of 5x subtract 2 is greater than or equal to 8. And we're just going to use 8 as just the example. If 8 was here and my numbers were bigger than 8, then the only way that I can have a number, because remember we're going to choose negative 8, so the only way that I can have negative 8 work would not be right here, because that wouldn't make sense. It wouldn't be greater than or equal to 8. The only way that I can do that would be to be on the other extreme. And the other extreme means to have an OR statement. And so I know I can't write that as a compound AND statement like I did before. I'm going to have to write this as two separate statements. Okay, so let's go ahead and do that. All right, so we have 5x subtract 2 is less than or equal to negative 8. Don't forget to put that negative there. And 5x subtract 2 is greater than or equal to positive 8. That one stays the same as we saw in the diagram. So we're going to add 2 on both sides of that inequality. And so we get 5x is less than or equal to negative 8 plus 2 is going to give us negative 6. And we divide both sides by 5. And so x is going to be less than or equal to, we can leave this as an improper fraction, or we could say 5 goes into 6 one time with 1 left over. And that way it would be easier to graph that. And then on the other side, we have plus 2, and what we do to one side, do to the other. We'll have 5x is greater than or equal to positive 10, and divide both sides. My pen has turned off. Let me just turn my pen back on. So we divide both sides by 5, and what we do to one side, we do to the other, and so x would be greater than or equal to positive 2. And if you were to put this on a number line, you just have to kind of estimate negative 1 and 1/5. But you'll see that if I was just to do a quick rough sketch with 0 being our origin, and 2 here, x greater than or equal to 2 would be a solid dot going in the positive direction, and negative 1.2 rather, would be a closed circle as well, heading in the opposite direction. All right, and so we have this like forbidden zone of no value. All right, so now let's use an example of tolerance. Now, tolerance means that you have an acceptable value, and sometimes you could be outside of the tolerance zone or within the tolerance zone. And if you can be outside and within, that means that you're dealing with the inequalities and even absolute value. So a cereal manufacturer has a tolerance of 0.85 ounces for a box of cereal. It's kind of like a plus or minus. It can go slightly above and slightly below, but it cannot go past 0.85 ounces and it cannot go below 0.85 ounces. And if you used to picture that, just picture that with as just a raw figure, then that means you do not want to go past positive 0.85 or below 0.85. And you can see all your values are in here. And just by seeing that visual, you know that you're dealing with an and statement in terms of inequality. All right, so let's go ahead and read the rest now that we got a visual understanding of what we're doing. Now, the box is supposed to weigh 25 ounces. What they want you to do here in this question, this is taken straight from it's been modified from the book. Write and solve an absolute value inequality that describes the acceptable weights for 25-ounce boxes. All right, so our absolute value is going to be the absolute value of our actual weight minus the weight we want, or as the book wrote it, ideal weight. And that's got to be less than or equal to 0.85. That's our tolerance. And we're using the less than or equal to sign as just as I painted the picture with the verbal concept that we want an and type statement. So we use the less than or equal to. And because we want to include the 0.85 difference, so we use less than or equal to. So our actual weight we do not know, so we put X. Our ideal weight will be 25 ounces. That's what we want it to be, with a tolerance of 0.85. And so now we have our inequality. And because it's less than or equal to, we can go ahead and solve it using our understanding that we just went over. And so that means that we're going to have on the left side negative 0.85. That's the lower end, as I showed with the little diagram. And that's going to be less than or equal to X subtract 25. And then we have on the other side less than or equal to 0.85. All right, so then we're going to add 25. And what we do to the middle, we do to all sides of this inequality. So the 25s will cancel. And on the right side, or in the middle, we're going to have X less than or equal to, start with the easier one first, 25.85. And if you subtract over here, you're going to end up with 25.15 or 15 hundredths. 24 and 15 hundredths. And there we have it. We have our possible weight. So that means if you were working for a cereal manufacturer like Kellogg's and they wanted that, you can create your own inequality based off of what they want. And you would have 24 and 15 hundredths is less than or equal to X, less than or equal to 25 and 85 hundredths of an ounce. All right, let's look at another one here, writing an absolute value model for tolerance. So this one is the opposite. It's where we have some information, and this one's straight from the book, I believe, and we're going to actually come up with an inequality. So you are a quality control inspector at a bowling pin company. A regulation pin must weigh between 50 ounces and 58 ounces, inclusive, meaning that you're going to include those values, 50 and 58. Write an absolute value inequality describing the weights you should reject. So first thing you want to know is what is your tolerance? And so you're going to have to use your number. All right, so let's go ahead and determine our different variables. For this one, you could start off with your verbal model. You're going to have your actual weight minus, and it has to be in between this. So in order to find the ideal weight, you can either put ideal weight again, or you can put the weight you want. In this case, we can do it by finding the average. That's how the book goes about it, but there's another way you can do that. In order to find out where your numbers can be in between, you could just simply say 58 subtract 50, which is 8, and then divide that by 2, which is 4. And not only does that give you your tolerance, but it also gives you what that number must be in between, the middle number. But you want to do your actual, subtract your average, and it's going to be greater than your tolerance. Now the reason why we're using greater than this time, greater than means it's beyond. And the last part of the question says the one you want to reject. And remember what we did before, the rejection could end up in the middle of an or statement. And because you want it to be on the other extremes, you're doing the greater than, as you want it to be an or style of a statement. All right, so now let's go ahead and look at how to do this. Our tolerance, well, to find our tolerance, let's do this on the side. Our actual is going to be W. And our average, you just find the average of the numbers. And to find the average of the numbers, you say 50 plus 58, that's 108, divided by 2, and that's going to be equal to 54. And therefore our tolerance, we can find our tolerance by just subtracting our average from 58, or the low from 50. And so we can say 58 subtract 54 would give us a tolerance of 4. So now we could go ahead and work this out. Our actual is going to be W. We've used W there. Our average is 54. And our tolerance, we're going to have greater than, where is it, 4. Right? And so if we were to solve this, because it's greater than 4, we're going to get two different ones, but they don't want that. They just want to write an absolute value inequality. But if you were to solve it, then you're able to find out the different extremes that you would have.